Well, today I turned on my spectrum analyser in order to repair a ICOM radio which has got a problem with the phase-up loop. But I turned on my spectrum analyser and it's developed a fault. Basically, it warms up. Basically what's happened here is we've got a screen of absolute garbage. I'm not sure what's going on with it. It was working fine last time I used it. So, I've never been in this thing before, so I have absolutely no idea what can be wrong. I don't know what generates the video at all. I've got no schematic diagrams for this thing. I know it's a CRT display. I'm assuming there's some sort of a video card which feeds the screen. I guess it's probably a good idea to try and do a little bit of logical fault finding first. Try and eliminate most things. I don't want to get right into pulling this thing apart. I much prefer to figure out just where the fault is, or a rough area where it is. It could either be the video card not giving the correct signals to the CRT display board, or it could be a fault in the CRT display module itself. It looks like a module. Basically it looks like it's got no horizontal sync. It's certainly not syncing up to anything. So how can we narrow this down without pulling this thing apart too much? I see at the back it's got a video monitor output. I might, before I go any further, I think I might just plug in some sort of a video monitor into the external output and see what we get. Now it's a composite video, it's only a coax and a BNC plug, so it's got to be some sort of a composite video signal. Whether it's just straight out TV compatible or not, I have no idea. But the next problem is I haven't got a TV here, let alone one with a VCR input or a composite video input. So let's see. Now the only thing I can find is a module that is out of one of those, I don't know what you call them over your countries, but we call them a handy bank machine, where a hole in the wall machine where you stick your card in there and it spews money out. I used to repair these things years ago, and a couple of these, most of these modules got replaced because of screen burns. In fact, this one's got Westpac, welcome to Westpac burnt in the front screen. But I kept them because we've got handy things like flyback transformers, line output transformers we call them here. And also CRTs can be quite handy too. They're rapidly becoming a thing of the past. I've no idea what frequencies these things run at actually. I'm pretty sure they're just PAL TV frequencies of 15 horizontal line frequency of 15625 or 15.625 kilohertz. Looks like old Daisy here's written down where the wires go, so let's fire this thing up, see if it actually works and what can we do with it. These run on 12 volts and they just take a standard, well, a reasonably standard composite video signal in. So let's turn that one on. What I'm trying to ascertain here is whether we've actually got sync pulses coming out of the video card and the spectrum analyzer, or whether it is in fact a fault with the module. If it's a fault on the digital board with whatever it has for a video card, well, we're going to be pretty stuffed because with no circuit diagram or anything, it's just going to be a no-go. I just haven't got the time to fiddle with it at this point. I've got so much work on it, it's not funny. So look, let's connect this video cable up to the video input of this thing. We'll see what we get out of it. Give us some idea whether we've actually got a video fault or a video card fault. It's quite important that we don't go pulling too many things apart. Like spectrum analysers are complex things, are a bit of a pain in the arse actually. Right, we'll turn that on. And we've got a similar fault. I don't know whether you can see that actually. And I'll turn the brightness down a bit and we'll see what we've got. Oh. Yes, we've got a similar fault where this is inconclusive. This is actually inconclusive. We've either got the same fault or not the same fault. Now, the next question is, what is the horizontal frequency that comes out of the composite video? It's probably, thinking about it, it's probably higher than 15625. Computer logic uses standard frequencies, usually derived from a master crystal, and the binary weighted or divided by a binary amount. So yeah, 15625 is not actually a standard computer thing. I'll change the, I'll see if I can change the horizontal oscillator frequency. Now, I don't have a schematic for this damn thing either. But I do know, by the process of elimination, we can figure out, because we know it's a horizontal oscillator problem we're trying to fault find. This thing, here's the, right, there's a chip down in there. If we trace the horizontal or the video in, which is the read wire, which is what, 1 pin 2, yes, that's the, that chip hasn't got a name, it's got a factory number on it. I have no idea what that chip is. But it's definitely the horizontal oscillator sync separator. What I'm going to do, again by the process of elimination, I've got a chip that's got an oscillator set up in there somewhere. And without knowing anything about it, yeah, it's surrounded with bypass capacitors. Manufacturers are pretty lazy. Most bypass capacitors are standard values like 0.1, 0.01, stuff like that. Anything with a weird value is likely to be part of a filter system or an RC oscillator, which is what this is. And that there is a 2200 picofarad, and it's the only one around in that part of the circuit. I'm going to make a guess. I'm going to say that that capacitor there is going to be the horizontal frequency timing capacitor. I'm going to whip that out of there. I'm going to raise the I'm going to raise the horizontal frequency and see if we can get this thing to lock. If we can get this to lock, that will prove that it's the monitor or the CRT module in the spectrum analyzer and not the video board. That's what I want to know before I start pulling things apart here. So let's use a bit of cold hard logic. So if that's a, what is that? Yeah, 222. If we go to a 0018 or something like that, what have we got lying around here? That's that one. There's a 1N5. Let's whack that now and see what that does. I just want to get an idea, that's all. If we can just get it even to sync up a little bit, I'll be absolutely bloody wrapped. Because that way we can... Let's turn that on and see what happens. Be careful all these. I want to short these out and crook the spectrum analyzer good and always. Right, what have we got there? Let's hook the wires on and tear her on properly. Come on, Bill. Well, look at that. Wasn't a bad guess, was it? We've got a locked display. It's not totally locked, but it's... You saw that, didn't you? Let's see if we can adjust that up a bit. Somewhere here we should have a... No, I'm going to slow it down just a tad. Let's slow that down just a tad. We'll put another... what have we got here? We must have something useful. What's that one lying? 100 picks, 150 picofarads. Let's see what that does for it. So that means our 15, what I assume was a 15625 kilohertz original horizontal oscillator frequency. The spectrum analyzer is obviously using something a little bit higher than that. God, what a nightmare. It's part and parcel of this job. It's wires everywhere. So I'm just feeding this with my 12 volt bench supply. Yep, we're certainly locking. Oh, not quite, but we're getting there. What happened? Just bear with me. I'm being a bit rough for this. I should actually be a little bit more scientific. Right, there's a semi-locked. Oh, bugger me. Just bear with me here, bear with me. These crop clips aren't the best. Right, we're not quite locked, but we're going to be any minute now. When I find the correct oscillator adjustment pot, which again is going to be a whole heap of guesswork. Let's see what we've got in here. Not the easiest place to adjust, unfortunately. That's the height. That screwdriver doesn't do anything. What else have we got here? Not very well designed, this thing, but then I suppose in all fairness, it's not as exactly, you've got to adjust it every 5 minutes. Once it's adjusted, I guess it's adjusted. Let's get that in there. Mind you, this is pretty irrelevant because I've actually now decided that the problem is with the display rather than the video board. So basically, without any test gear, we've discovered that we have in fact got a sync pulse. Whatever frequency it is, but it doesn't really matter. We don't need absolute. I don't know where that is. What's that one do? Ah, here we go. Yeah, we don't need absolute measurements. We just need something that. Oh, bloody hell! I keep pulling the wires off when I try and lift this up, and I'll get there. I'll get there. Not this time. Look what we've got. We've got a nice stable display. So that suggests that the only problem with the spectrum analyzer is the CRT module. So let's disconnect all this, turn the bench supply off, get rid of this, and turn the analyzer off. Disconnect the power. And let's whip out this module. I assume it's on there. It's quite a handy machine. I don't use it all that often, but it excels at certain tasks. I don't use it to its full capabilities. I mainly use it as an RF voltmeter. You stick the thing on 0 span, tune to the frequency you're trying to measure, and then just probe the circuitry that you're measuring. And I don't know what else holds that in. Oh, that one there by the looks. So yes, it's great for that. It's also good for things like monitoring the output of things like a comb generator, because these things have got quite a, well, they're old technology, but they're as reliable as Ah, there we go. Let's carefully get that out of there. I don't know if there's anything else holding this in. Doesn't seem to be. I should probably try and locate a schematic for this. The good thing with this older gear, that a lot of the, in fact most of the parts, you've got a chance of repairing it, and that said, you can keep a lot of this sort of stuff going almost indefinitely. You know, there's always the odd component that is specific to the task, but generally the older the equipment, they use more and more generic parts. So that's the device. Let's have a look in here. Now I notice we've got, you probably didn't see when I unplugged them because I wasn't concentrating on you guys, but we've got one of these cables that cable there goes to the video board, and we've got 1, 2, 3, 4, 5 wires. So I'm going to say that we've got a horizontal drive or a horizontal sync, either or. We've got a vertical sync, we're going to have a video input, we're going to have a plus probably 12 volts and a ground, and this cable here goes to the front panel remote brilliance control. So if we be really clever here, we can actually probably power this up while we work on it. That'll be good. Makes life so much easier. So let's put that back into there. Let's power up the analyser once more. Switch on. And we should once again have our, there we go, yes. I'll turn that off, you might be able to see that. There you go. That's what we've got. So now, I don't know what wire does what. So we're going to have to do some tracing. So we can again use logic in the process of elimination. I can see a fuse down on this board down there. So we've got a fuse there, so that's obviously the DC input. And that goes to pin 2. No, sorry. Yes, pin 2. Pin 1. Aha. Now, again, as I say, I haven't got a schematic for this, so I haven't got a clue what's in it, but I've nutted out, we've got 2 chips in there. We've got this one here, which has got a heatsink on it. I don't know whether you can see that or not. We've got a, can I do that without bugging? No, I won't touch the camera, I'll mess it up. We've got one IC here with a heatsink on it, so I'm going to guess that's a vertical output for the yoke. Yeah, that was pretty common back in the days this was built. And we've got a second chip down inside there, we've got a horizontal hold pot, a sub-bright, and a horizontal phase. Okay, so this side, this end of the board is obviously to do with the horizontal. Now, so if we follow that trace there, and it goes to there. What colour wire is that one? That's the blue wire. I'm going to make a guess. I'm going to say this blue wire here is going to be the horizontal sync pulse. I'm going to say that's the case. So let's switch that off again. Bit awkward to find the buttons because it's upside down now. So that goes straight into pin 1 of that IC. And there's no other components. That is that wire goes to that trace directly into pin 1 of that IC. So that is going to suggest to me, and this is a break in that wire. I haven't used any test gear, so let's not ruin it and start using it now. Let's just disconnect that one. I am going to disconnect it from pin 1. I wonder if it's possible. I wonder if we can sync, because we know there's a sync pulse getting to that chip, and the chip obviously isn't recognising it. It's not doing anything with it. So that's why we've got no sync. So maybe the chip's died. Why? I've no idea. But let's just try something. Right, this is that 2200 pic capacitor I took out of that other monitor. So let's just, I want to try and sync this horizontal oscillator directly. See if that works. Now again, I don't have a circuit diagram for this. And we know that's the horizontal oscillator chip. So now we need to find the timing, same as we did the other one. We need to find timing capacitor. We're not going to change it because it's obviously the right value, but what I'm going to do is try and inject the sync pulse directly into the horizontal oscillator. That's what I'm going to try and do. If I can find the right part there. Let's try that one. I'll take a stab at this and think, well, that might be the horizontal timing capacitor. If we take a capacitor off that, and we'll send a sync pulse in there via, God, I don't know. What resistors have we got lying on the bench here? Must be something we can use. What's that one? 4.7 k ohms. Perfect. Get a guess. So let's connect the sync pulse through a 4K 7 ohm resistor in series with a 2200 pic capacitor, and see if we can direct sync that. Be bloody awesome if it does. A little down. Well, look at that. That's unbelievable. That is unbelievable. It's not perfect yet, but what do you think about that? It's a stable picture. All we need now is to mess with the controls here a little bit. Let's see what we can come up with. I'm surprised that worked. Yep. Must be the sub bright. That's obviously the vertical hold. Ah, that's the one we want. Oh, look at that. I'm actually surprised that worked. I don't believe it. We've basically bypassed half the sync separator chip, and what we're doing is feeding the horizontal sync pulse from the video card, the video board, straight into the set. Now it's lacking a bit of width by the looks. We'll find out how to do that one. Oh, there's the height. That's pretty damn good. What have we got here? We've got a width coil perhaps. Ah, yes, I think we have somewhere. I just don't believe this. There's the width coil right there. Can we it's one of those horrible ferrite slugs with a hexagon adjustment thingy. A real pain. I hate things that aren't standardised. Let's see if we can get down into there with an Allen key. It's not the right way of doing it, but let's do it. Yep. Increase the width a little bit. I'd say that's not too bad. Look at that. Well, that's a pretty damn good repair. But will it sync up every time? I'll turn that off so you can actually see what's going on. It's as good as new. Well, now I've got two options. I'll either try and order an IC which is going to be pretty much obsolete and do a proper job by replacing that faulty chip, or else I leave this patch the way it is. mind you, I've learnt in the past, let's tidy that up a bit. I've learnt in the past, when you patch things up, they will always come back to bite you in the arse, always. That's better. Well, I don't know what to do now. I just think I'll leave it like it is. If I can get a chip, I'll get a chip and replace that. It's easy enough to get at. Or otherwise, I will just leave it the way it is. So, by way of an explanation, let me show you. Right, what we've got is a horizontal sync pulse coming in at whatever frequency. I don't know what frequency it is. That went into pin 1 of this chip. Next thing, I wonder what number the chip is. Hang on, let's have a look there. There's 8,000 volts in this thing. I should be a little bit more careful. Oh, I'd have to pull the board out. I actually can't see that. Anyway, that's pin, I think it's pin 1 off. Hang on. 2, 4, 5, 6, 7, 8, 9, 10, pin 11. That's a 12 pin SIP package. 12 pin SIP off pin 11. We've got a whatever capacitor, C question mark, that to ground. That's our horizontal frequency, I don't know whether you can see that, horizontal frequency timing capacitor. What I've done is disconnected that from the chip because it's not actioning the sync pulse, and I've rewired this through a 4K7 2200 picks, and now our sync pulse is applied directly to the oscillator. I am absolutely amazed that that worked pretty much straight away and is working as well as it does. It's not even tearing the video. That's what normally happens when you try and simplistically synchronise an oscillator. So all I can assume is they're extremely narrow sync pulses. Very narrow sync pulses. And of course we still don't know what frequency they are, but it doesn't matter. It's actually working. And it syncs up straight away each time. It appears to. Look at that. I'm very happy with that. So now if I can put it all back together and I can use my analyzer once more. But I will, I'll order the correct part for it and do a proper job on it. Okay, hope you enjoyed that. I did. Bloody awesome. I'm very, very pleased. Very, very pleased indeed. And one day I'll buy me a proper tripod for this camera instead of sticking it in the vise. Okay.